Yeah.
We're good.
So we want to welcome everybody to this
Just keep the
wonderful and
microphone near your
unusual
mouth.
shiur. We're very grateful to Dr. Noah Picard for agreeing to come here and share of his wisdom and of his Torah in many different fields. I want to, before I start, I just want to acknowledge a very special milestone in the community that very few are aware of. This evening happens to be Yud Chet Shvat, and it is exactly the 25th yard site of Rabbi Galernter, whose shul is across the street, and who was really the pioneer in this part of the neighborhood, the first shul in this part of the neighborhood. His son-in-law, Rabbi Savitsky, is now the Rav there. And I think that when Torah goes on, in this community, a large measure of the credit goes to Rabbi Galernter, and his name should be mentioned this evening in connection with that Torah, and he should have an aliyas neshama, and we are all the beneficiaries of what he did. This particular shiur is the brainchild of the Vad Harabonim of Queens, the Queens Vad, and the Sephardic Jewish Congregation and Center of Queens, and I'd like to acknowledge all the people who are here from those organizations, particularly Rabbi Marcus, president of the Vad, and Rabbi Hecht, the Rav of the Sephardic Jewish Congregation and Center of Queens. It's an honor that we at Etz Chaim can be hosting the event, and it's a particular honor to have this speaker here with us. He is the President Emeritus of Jerusalem College of Technology. He is the head of the Chair for Education, Mathematics, and Judaism, and he combines within his knowledge disparate fields of Torah, of mathematics, of science, of technology, and shows that Kala Torah Kula Inyan Echad, that there is a possibility of synthesis of these things in ways that very few people are able to synthesize, and we are honored now to present him for this lecture and shiur.
Thank you very much.
Just stand back. Just always think selfie, I tell people. No. Over here.
Over here.
Just always think selfie.
Oh, okay. Well, I must thank the Rabbi for his warm words. And as you can hear immediately, I'm not a native English speaker. So we will manage with somebody with a French accent and sometimes something Israeli, but I hope that it will be okay. Well, I'm especially honored to be here when you say that this evening is also Le'ilu Neshama of an important rabbi who was here, and I'm really impressed. This week is also the Askara of my grandmother, and she used, when she saw a nice landscape, she used to say it would be good to be here, to sit here and learn something here. Well, the topic we chose, this Torah point of view on space exploration, is one point of view, is my point of view. Of course, I will not say everything that can be said in that, but we will see a couple of examples. First of all, at the beginning of the Exodus, of Sefer Shemot, there is a verse that has very nice commentaries, and people generally don't pay attention to that. The first verse, "Ve'ele Shemot bnei Yisrael habayim Mitzrayma et Yaakov ish ubeto ba'u." Here are the names of the Bnei Israel who are coming to Egypt. Okay, names, and generally we relate to these names. Why to mention them? Because we had them already in the previous parasha, and so why do we need that? But this is a question that generally we don't ask, because we are obnubilated by what happens inside in the parasha, with Moshe who appears, and all the big events that are there. And we can see there in the Midrash, and Rashi mentioned this Midrash, that actually Bnei Israel are compared to stars. And that's what Shemot Rabbah says here. ואלה שמות בני ישראל הבאים מצחיימה יעקב ובניו איש ובטובהו שקולים הן ישראל כצבא השמיים. The Israel are equivalent to all these stars and all these objects that we have in the heavens. And then the Midrash continues and says that when we like something, when we like somebody, when we like stars, we give names. And so, during the last month, it was not a contest, but it was some kind of referendum, and the public has been asked, how would you like to call the exoplanets? And so a lot of them received names. I'm not sure that there are very Jewish names. All of them have been taken from, or almost all of them, from strange mythologies. But okay, to give name to something or to somebody is to relate with a big importance to that thing. So HaKadosh Baruch Hu likes Bnei Israel so much that it doesn't only give names, but he mentioned these names a lot of times. This is the first explanation when we read this Midrash and Rashi. But actually, I think that we could do it in another way. I will try at the end of the lecture to remember that and then to go back to that Midrash and to Rashi. If I forget, please remind me. Actually, the first source for that, for the Midrash or for Rashi, can be in the Zohar. בו וראו כתוב המוציא במספר צבאם שכל הצבאות והמחנות והכוכבים הקדוש ברוך הוא הוציאם כל אחד ואחד בשם איש מהם לא נעדר. It's not only that we are compared to the stars and the galaxies because we have names, but everything is coming out slowly, one after the other. There is some kind of order for that. Probably you can remember that in the Big Bang Theory, the world was a kind of soup of very hot plasma at the beginning, and slowly appeared atoms and molecules, and the big structures began to appear. At some time, stars and planets and galaxies and clusters of the galaxies and so on. So something appears slowly, the same way as Am Israel appeared slowly. But we have a lot of questions that we can ask here. Here it is. ויעש אלוהים את הרקיע, ויבדל בין המים אשר מתחת לרקיע ובין המים אשר מעל הרקיע, ויהי כן. So God created, or he didn't create, at that time he did. He performed something. And what he formed is the heavens, and he made a separation between water from above and the water from below. Let's say like that. So we have two kinds of water. We have water beneath, we have water at some place over there, and HaKadosh Baruch Hu made a difference between them. Okay. So we can have a look, and we know that there is something here in the clouds, that there is a lot of water on the earth, the ocean, or the seas. It's a lot of water. We never found such an amount of water on other planets. Scientists are looking for that. Oh, we have some reminders of the presence of water on Mars. Sure, not sure, maybe. On one of the satellites of Saturn, it should exist a very big ocean of water, because on other places there are oceans of methane. But we have water in the oceans, we have water in the clouds, but the water in the clouds is actually water from the earth. It's not something from above. Where could we find water from some place above our heads? Well, we could find this in the solar system, but we need to have a description of the solar system in order for this to appear. So we have the sun here in the middle, and we have here some orbits of some planets. For example, here in blue, it's Pluto's orbit. But there are a lot of things appearing in the solar system which we do not meet every day. We cannot. I wish we could, but it took to Voyager, to the two probes, about 30 or 40 years in order to arrive to that vicinity. But actually, we can have a look where this water from above can be. And so people tried to understand the solar system in a specific way. So you have here the Sun, and then Mercury, and Venus, the Earth, Mars, Jupiter. But between Mars and Jupiter, something is missing. And according to Kepler laws, something is missing. So people looked at that, and they found a belt of asteroids. And probably this belt, this is one theory, this belt of asteroids is made of the reminders of one planet which was there and exploded. And then we have Jupiter, and then Saturn. So in Hebrew it's Tzedek, Shabtai, and then Uranus, and Neptune, and Pluto, which is not a planet anymore, but a dwarf planet, as a decision of the International Astronomical Federation, or Union. But actually, if we look closer, we have here these asteroid belts between Mars and Jupiter, but we have also, after Neptune, we have the Kuiper belt. It's much greater, and there is Pluto. And Pluto is a small, very tiny object. There was an American probe who visited Pluto last year, so we have very nice pictures, and it was very interesting. But this probe went across Pluto and discovered other objects, and there are in this Kuiper belt bigger objects than Pluto, and they are very recent research show that theoretically there should be another object much farther, 10 or 12 billion kilometers from the Sun. We are at 150 million kilometers from the Sun. But at 10 or 12 billion kilometers from the Sun, there should be a huge planet the size of Jupiter, or maybe more. But now it's only a theory. It's a result of computation. Nobody saw that. But computations can be very useful. That's the way Uranus has been discovered. An astronomer, 150 years ago, made computation that said there must be a planet at such position. People look at that and found it. So we have objects, very strange objects, in this asteroid belt and in the Kuiper belt. And so a theory says that probably the water we have here on the Earth came from objects which have been expelled from these regions, from this Kuiper belt or asteroid belt, and then these objects have struck the Earth and left here this water, this huge amount of water. And so people began being interested in comets. So you have comets which are visiting the Earth every 3 years, every 6 years, every 7 years. And there are comets visiting Earth every 50 years, 100 years, and sometimes once, and we had no trace of what happened. And sometimes you have other comets, like Shoemaker-Levy, which was decomposed by gravitation and fell onto Jupiter. It's very nice. You can Google it and have tremendous pictures that the NASA has posted. But so many people think that the water came from comets. Here you have a picture presenting the new objects which have been discovered in the Kuiper belt, not close to Pluto. Some of them are much farther, and many of them are bigger than Pluto. And really, Marabu Ma'asecha Hashem, only to observe this universe, only the solar system, is amazing. To lie on the floor and to watch to the stars but you need to be out of town, and you can look. It's very nice. So the solar system is bigger, much bigger than what we are thinking. We have here the tiny thing. It's a solar system with the sun in the middle, but we have the orbits of the known planets, and we have what is known as the Oort cloud. It's much farther, we will speak about that in a few minutes. But meanwhile, you remember that these Voyager satellites, these probes, 2 probes have been sent by the NASA in order to explore. At that time, they explored Saturn, and they had a flyby, and they could see that. But meanwhile, I think that at least one of them, maybe 2, both of them went out of the solar system. The scientists could know that because now some kind, not the solar wind which came from behind, but something, the wind of particles coming from outside of the solar system is received in front of them. So they are very, very far from us, and they explored some part of this outer part of the solar system. But meanwhile, we don't know a lot about all these objects, and one theory is that comets can come from the belt between Mars and Jupiter. These are comets with a low frequency. They come every 3 years, 5 years. Some of them can come from the Kuiper belt, but some of them can come from the Oort cloud. The difference is that the belt of asteroids behind Mars is flat. It's like a ring. The Kuiper belt is also like a ring, but the Oort cloud is like a ball, a quite deformed ball. This is still somehow a theory, but this theory has simuchim. It is based on a lot of observations. And maybe there are some objects coming from there. So one comet is mentioned in the Gemara, in the Masechet Orayot, and 2 of our sages, Rabban Gamliel and Rabbi Yoshua, they were on a boat, and they wanted to share their food, but it appeared that one of them took more food than the other one. And then he was asked, "What happened to you that you took more food?" And he said, "There is something in the sky which appears every 60 years, and it takes all the skippers astray. Because you know that at that time, in order to find where you are at sea, you had to compare your position to the position of known stars. But if there is one extra star, every computation, every fixing of your position can be false. And a comet which returns to Earth and is visible from Earth every 60 years is the well-known Halley comet. So probably... What?
76.
Shivim Shan. Oh yes. I'm in a hurry because the Halley comet visited us a couple of years ago, and I missed it. I missed it. So I want to see it the next time. Amen. But actually, the Halley comet doesn't come every 60 years, but 70 years.
But the Gemara knew about Halley's come.
It's written in the Gemara, so it's true. We cannot say something else. But anyway, the question of the water is still alive. And so we had a very interesting experience during the last year, 1.5 years. The European Space Agency launched a probe named Rosetta 10 years ago, 11 years ago, in order for this Rosetta to visit a comet named Churyumov-Gerasimenko, a generally journalist called him Chury. And this probe, this is Rosetta, took with it on his back a very small laboratory robot named Philae. And at some stage, Philae landed on the comet. It was not so easy, and I suppose that you saw in the newspapers what happened with Rosetta and with Philae. But one of the missions of these objects, of this robotic laboratory, space laboratory, was to find water on Churi. And it was very, very interesting. I will tell you something not related to water now, but it's related to something I will tell you in a couple of minutes. And the way the probe went from the Earth to this Churi is a very, very complicated way. People think that if you want to launch a rocket towards something in the sky, you launch it straight. Never do it. It's impossible. Everything is curved in space. Every trajectory is a complicated curve, but not only that every trajectory is a complicated curve, but if you want to go from the Earth to something like that by the shortest pathway, you have to take with you a tremendous amount of fuel and oxygen. In order to do it with less weight, there is a method. The method is to use gravitation. Everything in the world can work in two directions, positive and negative. Gravitation is supposed to attract, but if you use it the right way, you can use it to push your probe. And that's what they did with Churi. And Churi began on a very small elliptic orbit, but this elliptic orbit brought, not Churi, sorry, Rosetta. And this elliptic orbit brought Rosetta once again close to the Earth, and then the Earth, the gravitation of the Earth, pushed it. It happened 3 times. Just a minute. Oh. I saw that I brought the simulation. No, I didn't. It's a mistake. But what happened is that actually the probe was launched, made one turn, and became once again close to the Earth and was pushed. And then the ellipse was bigger, and then it returned. Actually, the probe has been pushed twice by the Earth and once by Mars, and then it could be launched at a speed sufficient to go very, very far away, and then to come on an orbit behind the comet. You cannot meet something in the space face to face. If you try to do it face to face, it's called an accident. Everything will explode because they travel at tremendous speed. So you have to come from behind, and to arrive, actually the orbit and the speed are connected. So they arrive almost at the same speed, and so they can connect. This is the way you can go to the space, the International Space Station, and so on. And so that's the thing that they did. But in order to have this landing, even the trajectory of Rosetta around the comet was a very strange trajectory. So everything is curved, but not the same way at every place. It's not ellipses, it's not anything, but even the gravitation of the comet is so low that the Philae robot, whose weight on the Earth is 100 kilograms, on Churi it's only 1 kilo. Therefore, when he landed, it had all these rebounds, and the danger existed that he will be rebounded into the space and be lost. So it was almost lost. It didn't perform everything he had to perform, but it was, anyway, it was successful. But this is a description of the trajectory of Rosetta in order to approach the comet and then to orbit around the comet. But Rosetta orbits around the comet not because of the gravitation of the comet, but because of these engines. And well,
Did it work or did
Philae,
it fail?
sorry,
Did it work or did it fail? I think I heard it failed.
Philae worked
But it
60
failed.
hours.
No, it failed.
But it's out of the sunshine. Out of the sunshine, out of its power.
Yeah, no, Philae landed, worked with its batteries 60 hours, and then all the scientists tried to have it receiving enough sunshine in order to fill the batteries. The last time they had a contact was last June, and now it seems that this is totally lost. But even these 60 hours of data have not been worked out until now, and there is a lot of data from Rosetta also. But one of the things that they found there, they found water. Oh, wonderful. Because generally people describe the comets, all the comets, as balls of dirty snow. And so they found a lot of dirt. They found a lot of carbon, something very black. The comet is not white, the comet is black and smells very badly. But because they could analyze which kind of molecules they found there. But the only molecule which interests me is water. Yes, they found water on the comet. But what can we do? This water is totally different from the water we have on Earth. Water we have on Earth is the molecular H2O. 2 atoms of hydrogen and 1 of oxygen. But actually on Churi, they found that this water is made not with hydrogen at most, but with another isotope called deuterium. This is a heavy water used in nuclear plants. And the proportion of this heavy water there on Churi is much greater than what we have here on Earth. So if we have water here on Earth, it cannot come from comets like that. Statistically, it's on one object you cannot draw a conclusion. But at least it says that your theory that water has been brought by comets, it's still a theory. We have no proof. Meanwhile, other probes approach asteroids and other objects, no answer. Okay? So water above, water below. Of course, if you are looking in the books of Ramchal, and they have another explanation of what is this water in this verse, the water of above, the water below. But meanwhile, we have to explore the world that Akadosh Baruch Hu created, and then to try to understand not only on an esoteric, it's not nice to speak like that, but not only on an esoteric level, but to understand the world that He gave to us. And so we had to try something else. Well, I told you before that everything is curved in the universe. I will try to show it and why it's so important. Everyone has heard about relativity theory. Actually, Einstein has 2 theories of relativity. I will speak about the general relativity. Because general relativity is a theory of gravitation and not the special relativity. Special relativity is for a flat space where nothing is inside, or almost. But general relativity is for a space where there are a lot of big masses, something material exists there. And when you have a big mass, this mass provokes a deformation of the space, of space-time. The way there, this cat deforms the bed where he lies. And then what happens is that if you are throwing, say, a ball, table tennis ball, and you want it to go straight, it will not go straight. It will go on a curved trajectory. Exactly the same thing, our conversation this afternoon, that the trajectory of a plane, the route of a plane from Tel Aviv to JFK has to be an arc of great circle. So we don't go from Tel Aviv to New York straight west, but we are going north, and northwest, and then we are arriving in JFK from the northeast. Because trajectory, the shortest trajectory on a surface is what is called the geodesic. And the geodesic on a sphere is an arc of great circle. General relativity said that light is traveling on geodesics, and that the space-time is deformed by the presence of mass. Therefore, in our eyes, everything is curved. And this curvature is very, very important. First of all, in the general relativity theory, it was only a theory. It had to be proven by evidence, and this evidence has been found in 1919, where there was a solar eclipse. And Eddington went, there were two expeditions in order to observe that, because it was in the southern hemisphere, and Eddington could see that and could prove that it was right. How did it, the job, I forgot to put a picture, apparently. When the sun was occulted by the moon, we could see the stars. And these astronomers could reveal that some stars were not seen where the computations said they are, because of the deformation of the ray of light around the sun. And not only light can be curved, but everything, the trajectory of every material thing is deformed, the same way that this patchwork, which is flat, has been deformed by the presence of the cat and the presence of the cushion here. And so the trajectory are not straight the way we understand straight line, but what is a straight line in a curved space-time? It's what is called a geodesic. And for example, it can happen, this is a picture of a part of our universe. Every dot is a galaxy or a cluster of galaxies. And so the trajectory of light from this point to this point can be curved by all the masses of the galaxies and clusters of galaxies on their way. Why is this so important? It is very important because from one source in the space to us, the light may come by different pathways. And this can be, okay. And if suppose that we are here, and light comes out of this galaxy, it can arrive to us by this path, but it can arrive to us by other paths. This has been computed by Einstein, because the gravity, for example, when gravity is so powerful close to a black hole, that light is making loops around the black hole. And if you try to travel to the vicinity of a black hole, if you are still alive, because gravity will destroy everything that we approach, but somebody who would be close enough to a black hole would see in front of him the stars which are actually behind, because the loops, the spirals that light is doing in such a gravitational field are tremendous. And so maybe that we receive light from sources by different ways. Einstein calculated that, and after a couple of years this had been revealed by observations. And there is something which is named an Einstein cross, where we can see 4 galaxies which are actually one. But the light came from this galaxy very far away and passed close to a big mass, a galaxy or a cluster of galaxies, and has been deformed all around, and then when we received it, we have the impression that it comes from 4 different directions. But the light has been analyzed, and so astronomers could prove that actually these 4 galaxies are the same one. You can Google Einstein cross and you will find. Well, it's time to say something about what Chachamim say. For in the Gemara Masechet Chagiga, אין דורשים בעיירות בשלושה, ולא במעשה בראשית בשניים, ולא במרכבה ביחיד, אלא אם כן היה חכם ומבין מדעתו. Those among you who understand Hebrew understood. For the other one, we have here a translation. I'm not responsible for the translation. I took it from a website. So I'm not supposed to comment Maaseh Bereshit, the creations, in such a crowd. We are more than 2, so I cannot do it. Well, in Bereshit is written that ויגרש את האדם וישכן מקדם לגן עדן את הקירובים ואת להט החרב המתהפכת לשמור את דרך עץ החיים. Very complicated to understand what happened when Adam and Chava have been expelled from Gan Eden. And so God put there the flaming sword which turned every way. What that? Let's try. Have a look at that. A sword is supposed to be a straight line. But when you have a straight line moving very, very fast, what do we see? We don't see a straight line. We see a circle. We see a disc. We can have exactly the same thing here with a wheel. Everything which is straight here, suddenly you don't see it as straight, but you have a disc which masks the straight lines. This rectitude that we had in Gan Eden has been lost because of the sin of Adam and Chava, and then we have been expelled from the Gan Eden, and we are now in this world trying to find the way back to Gan Eden. And something is masking the way. It's all this curvature that we have in this world. Olam, it's the root of leha'alim, to mask something, to hide something. And so all this curvature hides the rectitude that we have to find, and this is our work to do it. Why do I speak of that? Let's wait. So in the same Mishnah in Masechet Chagiga is written that it's forbidden to comment Maaseh Merkava with a big crowd. You can comment Maaseh Merkava only with one student if he's clever enough, smart enough to understand by himself. And so you are giving him only the titles. So I don't comment Maaseh Merkava. Well, in Maaseh Merkava של יחזקאל is written ואראה והנה 4 אופנים אצל הקירובים וכו'. Ofan in Hebrew it's a circle. So a bicycle is an ofanayim. And you know from the prayer from Tfilat Shachrit there are some angels called ofanim. Probably these are round angels. I don't know. I'm not a specialist in the angels. It's quite hard to know something about stars, but angels. But anyway, ומראיהם דמות אחד לארבעתם. Yes, I'm here. And for their appearance, the 4 of them had one likeness, as a wheel would be within a wheel. So let's say we have a circle within a circle. These are 2 pictures of Saturn. One of them is a really picture which has been shot by Cassini probe, and the other one is the same picture that I return. I turn it bottom up. Which one is the genuine picture? You cannot know. I don't remember, but we cannot know. Because in space, there is no notion of up and down. This notion of up and down in the space is reserved to movies and for science fiction. So we don't know. There is no up and no down in space. And this is the problem we have with the malemala, malemata. What is up, what is down, we cannot know. This is a problem we have with a circle inside a circle. Which is the circle above? We don't know. Impossible to decide. But if you take a straight line, then this straight line divides the plane into two half planes, and in the upper half plane, the red circle is above the blue one. That you can decide. And in the lowest half plane, the blue circle, the little one, is above the bigger one. So you need this straight line, you need this rectitude in order to have ordering in your curved space. And this is one of the illusions of this sword moving around. You have to find this straight line, this rectitude, inside the whole world of everything which is curved. Is it possible? Maybe. So we have here this path of light, and here we have a Hubble picture from a cluster of galaxies named Abel 370, and actually the arcs you have are probably different images of the same galaxy. And so the light has been distorted by gravitation, by a gravitational lens which is in between. But we can find that all this curvature will have a very nice end. The prophet says that everything which is curved one day will arrive to a straight, to a flat, to a plane, something that we can do. And generally we think about these kind of prophecies as a moral issue. And when people don't behave in the straight way they should, and to say that they are torturous, there are words for that. But if we look at the newspapers nowadays, we don't feel that humankind is going towards something really straight and to be this rectitude will come. But the space can show it. We said that in space everything is curved. Yes. If you have here a star in the middle, you have what is called an accretion disk. And the solar system has been created by that there was a disk of dust and tiny material, and gravitation slowly created the planets and the comets and the asteroids. But everything was in one disk till now. And a lot of things are in one disk in the space. Look at that. Try to guess what's that. I will show it.
Supernova?
No. But you are in the good direction. A supernova is something which explodes. It's a star at the end of its life, and some kinds of. Look at that once. Oh no. Okay, I will tell you. This is a simulation prepared by the NASA more than 10 years ago. In the center here, you have a black hole. You know that a black hole is not a hole. Yes, it's a very dense object. And around it, there is an accretion disk, but what we had at the beginning is a neutron star. A neutron star is a very, very dense object. Such an object would weigh 100 tons.
That's it.
Because it's made of neutrons close to the other. We are made of material which is mostly empty. Yes. But this neutron star, the closest neutron star to the Earth, is now 150 light years. So we have time. But when this neutron star gets close to a black hole, the gravity of the black hole tears the neutron star and then transforms it into a cosmic blinches. And then all this material is going around, and slowly, I would like to say, falls on the black hole. But actually, when something falls, we think that it falls straight. But it goes around, it spirals, and then at some time, here you see the star being torn apart, and this blinches is now captured by the black hole. And have a look at what happens at the end of the process. We have two straight projections of material. Actually, this process, which is totally curved, totally spiral, ends with two straight lines. That is to say, that just have a look in the heavens, and the process that we described with this word, that the world which hides everything behind curvature, this can have an end which is straight. The observation of stars tells you exactly the same thing that the rock of Moshe in the desert said. This inert rock listened to the commandments of God, so you, human being, you can. All this domem, but it's only domem, all that. No neshama, nothing, okay? No life. Okay? Does exactly what we are supposed to do. And actually the Gemara said that if Torah had not been given to us, we would have learned a lot of things by observing. Tzniut by observing cats. Not to steal by observing ants. And we can learn that the end of all these tortuous ways of life is something straight, and the space is showing it to us. And you know what? This is still an artist's view. But this is a picture. This has been shot by an American space satellite called Spitzer. Spitzer make photos in X-rays. Not everything is done in visible light, but Spitzer found that. And you have this disk, and these perpendicular jets of matter. It was only in X-rays. Why? Because we don't see. So it's a consequence of Doppler effect, that even when light is emitted at a specific frequency, after it travels, and because of the expansion of the universe and so on, the wavelength is much bigger when it arrives to us than when it was emitted. Okay. But maybe we can remind that Chazal say that the light of the 6 first days has been spared by Akadosh Baruch Hu, because he saw that this world will be ruled by Reshaim, and he didn't want them to have profit, to have benefit of the light of the first days. But maybe we are the tzaddikim of this generation, and something of this light is appearing slowly. So it doesn't appear to everybody, it doesn't appear to the regular people on the earth, but astronomers are our tzaddikim doing this kind of work. And so something of this light from Bereshit is beginning to appear. I don't say that we will see this exactly in visible light, but one day it will happen. We will see something, because we discovered that a lot of astronomical phenomena occur much closer to us than what we thing. And it begins to be a little late. I'm not sure. You will tell. But the Psalms, David HaMelech tells us that we have to observe the sky. And that the observation of sky tells us a lot about the glory of God and the way we have to behave. So the observation, not cats, not ants, but to observe the sky. Yeah? Hashamayim mesaprim kevod el. The sky, the heavens, are telling the glory of God. It's important. And that's what we could do. These two guys are Arno Penzias and Wilson. Penzias, this man, this is Wilson. They were engineers at Bell Laboratories in the 60s. And they tried to fine-tune this antenna for intercontinental telecommunications. And they couldn't do it because there was always noise. And the noise because of other antennas, and tried to do the work at night, not to be disturbed by sun and so on. They didn't succeed until they understood that what they had, this noise, is what is called the cosmic fossil radiation, or the microwave radiation, the first radiation which has been emitted in the universe 380,000 years after the Big Bang. And so this radiation exists all over the universe and arrives to us as a microwave radiation at a temperature of 3 degrees above the absolute zero. And what they saw at that time, this is a map of the universe at that time, in the 60s. In the middle, it's stronger because it's a Milky Way. And then in 92, NASA sent a probe named COBE. And this is a map of this radiation they obtained. Here is a Milky Way. And then in 2003, the NASA sent WMAP and had a more precise map of this radiation. Once again, this is a Milky Way. And the difference we have here between the green and the blue and the red is a tiny difference in temperature. And so these germs are the germs very close to the Big Bang of the big structures which appeared after that, galaxies and clusters of galaxies. As it's not precise enough, the European Space Agency sent a new probe. It was 4 years ago, Planck. And 2 years ago, Planck released this map of the same radiation. It's more precise. You can see that the dots, the pixels are well defined here. And actually, this gives a picture of something in the history of the universe. And this represents the Big Bang. This is 380,000 years after the Big Bang. And then the evolution of the universe, and with the creations of atoms and molecules and slowly dust and planets and stars and galaxies and so on. And we are here in a universe where we have a lot of galaxies above our heads. But then came an astronomer, a French one, named Jean-Pierre Luminet, and he's looking at something in the sky that I will describe to you after that. But meanwhile, we have to look at that. This is a text in the Gemara Shabbat telling us that there is a big interest in making astronomical computations. Kol hayodea lechashev tkufot umazalot. Tkufot, it's time. Mazalot, it's constellations. To make computations about time and constellations, it's space-time. So the Gemara says you have to be busy with relativity. And but actually, the Gemara says in the name of Bar Kapara that somebody who has the ability to learn, to work in astronomy has to do that. Somebody who doesn't have this ability may be exempt on that. But then the Gemara continues, and Rabbi Yochanan says, "Minayin shemitzvah al ha'adam." It's a mitzvah to compute constellations and time, Tkufot u'mazalot. If it's a mitzvah, everybody has to make an effort in order to do something like that. And it's not if you have the ability, but it's a mitzvah. If it's a mitzvah, it's really much more important. But anyway, this Gemara says it's important to work in that, to make computation, to understand what happens as far as you can. And maybe you can learn it at the university. Maybe you can do it only by reading the newspapers, and when they announce something from the NASA, from the European Space Agency, or the Japanese Space Agency. And so you are updated and you know. And why? Because somebody who can and does not do it, this reveals that he's not interested in the creation that God did. And in another place in the Gemara, in Masechet Sotah, if I am right, the same verse is used by Chachamim in order to describe somebody who has a lack of emunah. Not to be interested in the world that God created is a problem of emunah. And that's exactly what the Maharal says. Here is a translation. And why do we need